Okay, and in this tutorial, I'm going to show you how to construct a tree by hand. And we're going to be using two different methods, the distance method and the parsimony method. So first, I'm going to be going over the distance method. So here we have the set of data we have here. We have four sequences in an alignment already, and these are the positions 1, 2, 3, 4, 5, all the way to 9. And now we first need to set up the distance matrix. So we're going to count the difference in the alignment between sequence 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4. Okay? So in this position, sequence 1 and sequence 1 are being compared, and you're comparing the same sequence, so the distance is going to be 0 because there's going to be no difference between the two. And then we'll have sequence 1 and sequence 2 being compared. So I took sequence 1, sequence 2, I took them in the alignment, and I calculate, and I just count where they don't match, where there's mismatches. And there's 3 mismatches, so I'm going to count that as the distance. It's similar to calculating the Hamming distance. Then I do the same thing, sequence 1 and sequence 3. So I scroll down, sequence 1, sequence 3. I count the mismatches here, so there's 3 right here. Then sequence 1 and 4, there's 5 mismatches, and I put this in the matrix. And then I look at sequence 2 and sequence 3, because sequence 2, sequence 1 have already been aligned right here, and sequence 2 and sequence 2 there's no difference, so it's going to be 0. And then sequence 2 and sequence 3 will have a total of 4 mismatches, or Hamming distance of 4. And then sequence 2 and 4, we have a total of 2 mismatches here. And then sequence 3 and sequence 4, going to align them and count their mismatches. There's a total of 4 mismatches. I'm going to put that in the matrix here. Then I'm going to find what sequences have the shortest distance from each other. And as you notice, you have sequence 2 and sequence 4 have the shortest distance from each other, a Hamming distance of 2. So we're going to put those together in our tree building process. So we'll have 2 and 4 together. You can think of it as a clade. It wouldn't technically be a clade because this tree is going to be unrooted, but you can say that these are going to be more similar these two are going to be most similar compared to any other comparison. Sequence 2, sequence 4 are going to be more similar to sequence 2 and 1, or 2 and 3, and so forth. So shortest distance, put them together, and then we're going to move on and calculate the average distance from the 2 sequences to each sequence. So we'll take these two. So from sequence 1 to 4, this distance is going to be 5. Sequence 1 to 2 is going to be 3. Then we are going to divide that by 2, get the average. We're going to add them up. Okay, and then we'll get 4, and that'll be our new distance. So all we did is we took sequence 2 and sequence 4. Okay, we took the distance because we're comparing. We're going to treat this. As just one whole sequence. Just pretend that it's just one whole sequence for now. That helps you. And we're going to figure out the distance from these two compared to 1 and 3. So we'll find first by taking sequence 2 and then seeing how far it is from sequence 1, right? In this case, if you see it right here, sequence 1 to sequence 2, it's 3. And then sequence 1 to sequence 4, it's 5. And then we're going to add them up. We get 8, divide that by 2, and we get 4. So we're going to put that in our new tree. So you can think as for this node here, right here, the average distance from 2 and 4 from this node to sequence 1 is going to be 4. And we calculated that we just calculated that by taking the distance from 1 to 2, 1 to 4, adding those distances together and dividing by 2, and that's the distance. And then we'll do that for sequence 2 and 4 compared to 3, right? So you would take sequence 2 and see how far it is from sequence 3. Okay, so you'll take sequence 3 and then sequence 2, so right here, 4. So we have 4 right here. Then take sequence 4 and see how far it is from sequence 3. Sequence 4, sequence 3. That's going to be, we're going to add that to the total distance so far. Divide that by 2, since we're trying to find the average. And then you get 4. So that would be the distance from this node to sequence 4. Oh, not 4. 3. Okay. So we will go back, make sure I don't erase anything I want to keep here. Okay, so that's how you do the calculations for that. I hope that's clear. Do that for each one, and then you'll get this new matrix, and then we'll look at the shortest distance. So from sequence 2 and 4, sequence 3 and 1 have the shortest distance from each other. Sequence 1 and 2, 1 and 3 are the shortest distance. So we add on sequence 3 and then add on sequence 2 in the next one. Right here. So sequence 1 and 3, sequence 2 and 4. And then we calculate the new distance. All you're going to do is take sequence 1 and then find the distance to 2 and 4, to the node 2 and 4. So sequence 1 to sequence 2 and 4 is 4. Okay, and then the sequence from 3 to 2 and 4 is 4. Add them together, divide by 2, and you get 4. So these will be the distances from each other. And this will be the final matrix. And this is your tree using the distance method.